Hello everyone, my name is Daniel and I'm a programmer and an artist. This video is going to be part 2 about making modular modifiers. We're building a road system that's going to be made up of multiple different modifiers that when we're done with it you should be able to stack in different orders and stuff. So you'll add a base that'll set up some overall parameters, and then you should be able to add, once we're done with it, curbs and railings and road surfaces and I don't know what all. So that's what we're working on. So far we've taken an input curve and we've snapped it to a terrain, and then we have created a boundary curve around the outside of it by turning it into a volume and then a mesh. Doing so, we made the assumption that our road system is going to be two-dimensional, and doing that removes the ability to have like bridges and things like that, but simplifies the problem in ways that are useful for some things. For this video, the point I want to try to get to is having the road have a surface on it. We might see about getting intersections in there. We're gonna build a road utility node that splits our parts that we merge together back apart again. So most of our modifiers will begin with this road utility node, or essentially a separate road components node, and then at the end we will join or append whatever we've created in that node into the geometry that contains all of the stuff we've made. So far we've got some curves. Let's make a new modifier. And in this modifier, we will do a separate. Oh, also someone asked if I could make this brighter. If we separate, so first thing we want to do is make this utility node. And we'll be able to add as we add more road ID numbers to our outputs, we will tag them all in this utility node and to separate them all apart again. So this is pretty simple. We need a named attribute. It should be the road ID, and then we can just say, is it equal to 0? That's going to be our control curve. And then we can make this a group. And then we'll want another one here. Is it equal to 1? So far, that's all we have. So this would be our center curve. And this will be our boundary curve. And this is our roads geo. So we will add more things to that. Roads util. So this is a helper node that we will need to use in a bunch of different, and basically all of the modifiers. So then here we could call this node road surface. And to make the road surface, initially what I want to try to do is just fill the curve. So we'll do a fill curve with triangles. And let's turn on the wireframe a little bit. That looks fine. Now, when you fill a curve, it flattens it completely. So we need to do something about that. Sometimes you can get lucky and the indexes of all the vertices remains the same, but it's not reliable. So we actually have to capture an attribute on our boundary curve, and we want to capture a vector that's the position. Then we want to set the position of our boundary curve to the position multiplied by x and y but not z, and we'll set that to be the position. So now we flattened our boundary curve. Then we want to convert that to a mesh because you can't sample off of a curve. Then we want the sample nearest, and then we want to sample an index, and we want to sample a vector off of the index, and that should be our position that we captured over here. And then after we fill our curve, we want to set the position of the filled curve to the sampled nearest index of our original curve with the position that we captured before we flattened it, which will restore the height to the mesh. So now that we filled that, there's a bunch of things we probably need to do to it. The first thing we might want to do is just add an offset to it. So let's put a combine XYZ. And we'll expose Z to the input. And we'll call this the offset, which we may want to actually put on the base so that like shoulders and things all use the same one. But we will leave it here for now. Let's set a default of 0.2 or 0.1. And it should be a single value, and it should be a distance. So now we have some geometry filling our road, and it should, if we make this road wider, that should still work. Now, one of the things that will immediately become apparent is that the terrain underneath isn't affected by this. And that's kind of a problem because we can't actually edit the terrain because we'd create a feedback loop because we're snapping our roads to the terrain. And if we wanted the roads to cut away at the terrain, that would change where the terrain was, which would change where the roads got snapped to, which would change where the roads cut into the terrain, which would change where the roads snap to. And you would loop forever, so you can't do that. What we can do is we could make a linked duplicate of our roads curve, so they share the same object data, and we could clear all of our modifiers off of it. And then let's just scale this flat. And then on our terrain here, we could add a roads TerraNode modifier, or you don't have to use TerraNodes. You can just have a mesh. What I'm saying is you're going to have to prepare where you want your roads to go separately from creating the geometry of the road, which is kind of annoying because it'd be nice if the tool could do it all at once. But I guess in this way you kind of can by having a linked curve. But so then if we select this guide curve, that will flatten our roads for us. We can snap that to the terrain. Make it a little bit wider. All right, now that we've filled our curve with triangles, it'd be nice to put a texture on it, a material. And to do that, we need UV coordinates. And to get UV coordinates, we would waste a lot of space if we just unwrapped this. So we would ideally like to put seams in somewhere in here to separate the different parts of the road. So I'm thinking the way we can create seams there is by comparing the difference in the index of the nearest point on our centerline curve. So let's do a couple things. First, let's hide this. And let's go back to our road base, and let's actually snap our original geometry to the terrain. And I think we can just do that by doing a set position. To our raycast here, because we can use that same raycast against the terrain. And then that will work everywhere except where there are points off the map. Oops, deleted it. So then we'll just delete all of the points that are at 0. So position equals 0, which I think, so you could also first, the other way to do this would be to delete the geometry that's not a hit, kind of like this, and then set the position. But that, I believe that causes the raycast to be evaluated twice, and raycast is kind of a slow node. So I think it's actually faster to set the position. All of the points that don't have a valid raycast hit get set to 0, 0, and then you can delete all the points that are 0, 0 Theoretically, that might be slightly faster, or maybe it doesn't matter. I don't know. But that's why I did it that way. So let's see. That does not look right. Oh, I think we need to evaluate this curve first. So let's do a resample. So let's do a resample curve, and we want to resample to, we can either do evaluated or length. Let's do evaluated for now, and if we want to resample it to a length, we can do that later. So now on our road surface, that should make sampling the nearest point off of that curve more reliable. So over here, we can take our centerline curve, put that into a reroute. And then we want to sample from it. So we need to convert it. Let's see, we need to capture an attribute on it. Well, I guess we don't. So we need to make it a mesh to mesh. Then we want to sample the nearest. And all we care about is this index here. So then on our, turn this back on our filled curve mesh, we want to compare the index. Let's see, we want to capture an attribute that's an integer, and we want to capture the index. We want to evaluate that on the domain of the face. So evaluate on domain of face, and then we want to capture it on the face corner, because we want to compare when the faces on either side of an edge have very different indexes. So we've captured the index on the face corners. So now for each face, we want, so let's see, now we want to do an unwrap. And we want seams. So we're going to capture, we want to store a named attribute. This should be UV map for the name. That should be exposed to the input. And we'll call it UV name. Then this should be a 2D vector on the face corner, like this. And now we need seams for our UV map. Just to see that this is working, we can do a set material. This should be exposed to the input as well. Let's make a material. Call it road. Let's add an image texture. I know I have a road here somewhere. We'll load this texture up, get material textures, go back to our geometry nodes. Then on our modifier, let's set that material road. So you can see everything's unwrapped now, but our UV unwrap would essentially be the bounding box of the mesh right now, which wastes a ton of space because we don't have anything in these areas. So instead, let's try to add some seams. And the seams we want to add are going to be where, so we want to sample the face corner. So we need some sample index nodes here. And we want to sample this index value. And we want to sample it from this mesh. And we want to sample 2 of them. And the index we want to sample is the corner of edge. Corner index. And the edge index should be the index of the edge, because the seam, so this seam value here is evaluated on the edge. So the domain we're working in is edge. So the index node will output an edge index. So then when we have the edge index, we want to get the corner of that edge, and we can choose which one we get by changing the sort index. So we'll look at the first one, and then we'll look at the second one, and that will get us one corner of the 2 faces on either side of the edge. But because we captured this value evaluated on the domain of the face, all of the face corners of that face will share the same index value. So it doesn't matter which corners we sample. And then we can subtract these from each other. and that'll give us a number that's the number of indices between the two faces, which if they're side by side on the mesh, it should be similar number. But they could be negative because we don't know which one came first. So we need to do an absolute to make if it's a negative number, that'll make it positive. And then once we have this positive number, we can say, is it greater than something? And that'll be our seam. So let's say greater than 5 and see if we view this, what does that get us? That is not what I was expecting because we were sampling the point at the face index. So change these sample index nodes to face corner. And that looks a little more like what I expected. Unless it is working and I'm just not... Oh yeah, it is working. Okay. I don't know why when you view a value on the edges, it never makes sense to me what you're looking at. Oh, you see, it says true here. So that's actually helpful now that you can see that. But I don't know why it fills in the face like this. I feel like it should just draw like a wireframe. Anyway, so it was working the whole time. All right. The other idea I had was to use a grid and then delete things that were far away. So I guess we could show how that could work as well as an alternative way of doing the road surface. So let's make a new geometry nodes modifier. And we'll call this road surface 2. And some idea for this one is, let's turn off the first road surface. Some idea for how this could work is we could again fill our curve. So we need to separate, we need our road utility. And we want to get our boundary curve and fill it. And then we could either create a grid, or we could, if we're using a grid-based terrain, just copy the terrain. So since we have that, I guess let's do that for now. It's going to be the input, should be relative. We want to realize the instances, and then we want our terrain collection selected. Then we want to do a ray cast against our filled curve. So ray cast, like so. And then we want to, and the ray source position should be the position. And we need to add like 50 on the z-axis to make sure it starts above. And then we want to delete the geometry here. We want to delete faces. And then we can set the material to our input of a material, and we can select our road material. And the faces we want to delete are where there's not a hit. So we'll say not is hit, like so. So now we're taking our filled curve and we're ray casting against that. And wherever it hits it, we keep the quad, and wherever it doesn't hit it, we delete it. So that gives us this, which is obviously very jagged. But that shouldn't matter if we also adjust the height. So then from our filled curve, let's do a proximity. And it will say, I mean, honestly, proximity could just work better in general. So let's get rid of the ray cast. We don't actually need that. We want our position, we're going to need to multiply the position times x and y, but not z. And we will sample the position there. Then if the distance is greater than, say, 1, let's delete that. So that gives us what we had before, but also a 1 meter boundary. And then we can take this distance value and subtract it from 1. And then we need to, so now it goes 0. So then we want to subtract 0.5 from it, and we'll multiply that by, say, 0.2, which is our height value essentially. And then but our height value is, we've offset it by half, so our height value should be double that. So we want to multiply times 2, and then let's make this an input. Oops. Do 0.2, we'll do an input, and we'll call this height, or offset. I always go through at the end and rename all of my properties because I don't want to spend too much time thinking about it right now. So now this is our scaled z value for every vertex in the mesh. So we need to set that to a position. So let's move this over here and allow it to set position. So now we've calculated a value based on the proximity of each vertex to our filled mesh that we raycast against. So the filled mesh is here. If it's over that mesh, then proximity should be approximately 0. But then at the edges, it gets farther away from it and goes up to 1, because we said delete everything that's further away than 1, which is how we got this edge here. So then all the vertices between the boundary of the filled curve, or the filled curve and our terrain, go from 1 at the outside to 0 at the inside. So we flipped that around by subtracting the value from 1, so that it goes from 0 on the outside to 1 on the inside, because we want that to be high. And then we subtracted 0.5 from it, so it goes from negative 0.5 to positive 0.5. So then we multiplied a value by 2, that's our offset, and we're going to use that as an offset for the z channel of the position vector of all the vertices in the mesh. So we need to combine x, y, z, and we plug this into z, and now the edges should go below the terrain, and the middle rises slightly above it. Now the benefit of doing it this way is that the terrain is guaranteed to match. It'll all be above the terrain underneath it, whereas with our triangulated method, I think all the problems are gone now, but initially there was that hole here where the terrain poked through and we had to flatten it more. So with this method, if we turn off on the terrain our road modifier to make it bumpier, you can see right here we got a problem on the triangulated mesh because there's a little rise here, and we'd have to push the road further up to cover that, or we'd have to modify the terrain in some way. But with our second method, that bump gets transferred to the road as well, which means our road's less flat, but it's all above the terrain. Even if we pick a tiny offset of like 0.01, it'll still be above everywhere. Anyway, so that's two different ways of creating a surface for this. Now, if we want to continue adding more things to it, we need to merge back in our curves that we use to create the mesh. So we need to do that on both of these, and it's pretty simple how we would go about doing that. So let's turn back on our roads here. So this is our first method, filling the mesh with triangles. We need to capture on this an attribute, and it should be, or no, we need a named attribute, and we want to capture an integer and on the points, and it should be called road ID, same name as in the base, and this will be ID 3 because I think I want to have points at the intersections, and so I'm going to reserve integer number 2 or ID 2 for that. So now we have this. We needed to join it with the input geometry. So we just add our input, take the geometry and plug it into there. We can hide the rest of that. So now we have should have the curves as well as the filled mesh in there. And then in our group that we created for our roads utility, we can come in here. We can make another copy of this. We can save a spot for our intersections, and then here with 3, we can plug this in here and call this road surface. All right, and then we can do the same on road surface 2. I don't see any reason why you would ever need both of these. So we'll just do the exact same. We'll store a named attribute. It should be an integer called road ID, and it should be number 3. And then we'll join with the input like so. There we go. So now we have the road surface in there. If we didn't think we ever needed to use the road surface for anything in future modifiers, which I'm not sure if we do or not, then you wouldn't need to tag it. Well, you probably would still want to tag it. That's where it comes down to a question of how you do it. We made this initial curve right here be ID 0. That might be a bad idea because anything that gets added, joined into the mesh without the road ID being set first will be given ID 0. So it's probably better actually to go to our base. And for our road ID here, let's add 1 to everything. So we'll make our center line curve 1. We'll make our boundary curve 2. Then we need to edit that on this one as well. So we'll say if it's 1, that's the center line. If it's 2, that's the boundary curve. If it's 3, that'll be our intersections. And if it's 4, that'll be our surface. So then we need to go to the surface. And let's make this 4. And this one 4. So that way if we add anything into our road without tagging it, it becomes 0 and it's sort of like an undefined part of the mesh. Probably just something we want to render, but doesn't need to be used by any other modifiers for anything. So that's probably a smarter way to do that. Yeah, I think that's probably pretty good for this one. Please note, as I'm making this, it's probably not the final version. I'm probably going to change 50 things about it before I'm done. I would expect that something will not... I expect that at some point I will try to add a node or something that will break some aspect of what we've done so far, and I'll have to go back and account for that in some way. It's a pretty iterative process. I try to take it one step further and then go in a different direction, because when you go in that different direction, you find out all of the things that you need from whatever you were working on before. So for example, one thing I definitely will want to add are like parameters. If say we use the second surface method, the UV scale right now is tiny, and I'd want to be able to scale it in as a, probably have a setting to scale it or something. Also on this road surface, the more roads you added, the bigger the texture would get. So that's not very great. So you'd probably want a way to scale it based on the area or something so that it remained at like a constant size. So there's a lot of features that still need to be added, but this is one step further, and we'll see where we go in the next one. So anyway, that's all I got for this one. Hopefully it was interesting, and thanks for watching.